Hello everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we'll be discussing on some tutorial question bank that is related to Module 2, Bipolar Junction Transistor. So how the questions will be asked based on Bipolar Junction Transistor. We'll be looking at some analytical questions and some descriptive questions on Module 2. So this question bank has been uploaded in IARE website. So yes, you can go through that. And in that, I will discuss the questions related to Module 2, that is the basic questions on bipolar junction transistor. So we'll have various three types of questions: short answer questions and long answer questions and analytical questions. That is, in analytical questions, we'll have mostly problems. That means how to solve the problems. What should you write for the given question? What the answer you should write for the given question? If it is asked for a long answer and short answer, I'll be discussing here. So first, we'll start with problem solving and critical thinking questions. So here, as we all are aware of all the theoretical concepts and mathematical formulas related to the transistors, so we'll discuss some problems on bipolar junction transistor, that is transistor. So a CE amplifier is drawn by a voltage source of internal resistance Rs is equals to 800 watts. Sorry, it is not watts, it is ohms. Rs is equals to 800 ohms and RL is equals to 1000 ohms. The H parameters are HIE is equals to 1 kilo ohm, HRE 2 into 10 to the power of minus 4, HFE 50 and HOE is 25 microamperes per volt. So these are all the parameters given, and he asked us to find the current gain AI, RI, that is the input impedance, and AV, which is the voltage gain, or not, output impedance, using the exact analysis and also the approximate analysis. And this kind of solution is also applicable. So the same kind of problems with the change in numericals are given in the problems, that is 2 and 3 problems are also of same kind. So if you go through the solution of this problem, you can even solve the second question and also the third question in the part A, which is problem solving and critical thinking questions. So let us try to find the solution for this one. So what he asked us to find current gain AI, RI, AV and R0 using H parameter model. So for solving this, first you need to draw the common emitter amplifier circuit with basic circuit diagram of common emitter amplifier, including the resistance Rs, which is of 800 ohms, and RL 1000 ohms. You have to draw like this. So that is Rs here, and the transistor is connected in common emitter configuration. So the emitter is grounded, whereas the input voltage is connected to this. So this is Rs, whereas the input is Vs, or else we can also call it as input signal, AC signal, Vm sine omega t. And here we do have a load resistor connected to this, across which we will be measuring the output voltage, and this is connected to plus VCC, right? This is load resistor RL, and across which we will be measuring the output voltage V0. So this is the basic circuit. And he also mentioned the H parameter values. Those are given here. So these are the given values. Rs value is given, which is 800 ohms, and RL value is given, this is 1000 ohms. And now, after drawing the common emitter amplifier, even though he didn't ask, we should draw the circuit diagram and its H parameter equivalent circuit. Its H parameter equivalent circuit, you all know that transistor H parameter equivalent circuit at the input side includes HIE, this is input resistance or else impedance, and in series with an voltage source. So where the voltage source, the magnitude of this voltage source will be HRE into VC, because this is common emitter configuration. And at the output side, we have a current source whose magnitude is HFE into IB, and we do have an admittance, that is 1 by HOE, and this is the equivalent circuit of transistor, where this transistor is also having another resistance in series with the voltage source, which is RS. Those should be connected as it is. So this is VS, this is RS. And here, as this is the input port, this is the base terminal and this is the emitter terminal. And now this is the collector terminal. So here, the current flowing through this is IB and the voltage drop across the input port is represented with VB, whereas this is VC and the current flowing will be given by IC, and we do have a load resistor connected to the output terminal, that is connected to the connected to the ground here. So this is RL and the current flowing through this RL will be considered as IL or else I0. So this is a H parameter equivalent circuit. First you have to draw the amplifier circuit and then draw its H parameter equivalent circuit. And you have to remember all the formulas, that is AI is given by minus HFE by 1 plus HOE into RL. So where you know the RL value, HFE, HOE are all given. So you can find out the gain. Just simply by substituting all these values, you can find out the current gain value. So you all know that current gain does not have any units. It is a unitless parameter. And one more thing, the input resistance. The formula for input resistance is HIE plus HRE into AI into RL, where if you substitute II value, you can also write down the RI value or else RI expression as HIE minus HFE HRE divided by 1 plus HOE into RL. So this is the equation for that input impedance. So you can even calculate the input impedance. So this is the input impedance. So if you have any other circuitry like R1, R2, actually it is not given in the problem. If you have R1 and R2 in the input side, then you have to, whenever you are drawing the H parameter equivalent circuit is nothing but AC equivalent circuit. Whenever you are drawing the AC equivalent circuit, all the DC sources must be grounded. If I ground this VCC, this R1 will also be connected in between this base and emitter. That means R1 and R2 will be in parallel. So that is RB we have to define, that is R1 in parallel with R2. And similarly, the total input impedance, by considering this RS also, then I can write it as RI in parallel with RB. So this you have to remember. If some biasing network, that is a potential divider biasing is provided, then we have to go for this formula. So this is input impedance. Now coming to the next one, he also asked us to find voltage gain. The formula for voltage gain is AV is equals to AI into RL by RI, where RI just now we have calculated from RI formula. Just substitute that RI value, then you will get the value for AV. This is also a dimensionless parameter. That means we don't have any units for gain, because gain is defined as the output voltage to the input voltage. So it is not having any dimensions. Now output resistance, the formula for output resistance is R0 is equals to RS plus HIE divided by RS plus HOE into delta H, where delta H is given by HIE minus HIE into HOE minus HFE into HRE. This is the formula for finding out the R0 value. So for solving this problem, we have to remember all this formula. If you are not able to remember this formula, you will not be able to solve this. So just substitute all the values. So you will be getting, you will be finding all the parameters like voltage gain, current gain, input resistance and output resistance. So that is the first problem. Coming to the second one, the transistor operating in a CB configuration has IC is equals to 2.98 milliampere, IE is equals to 3 milliampere, IC naught is equals to 0.01 milliamperes. What current will flow in the collector circuit of this transistor when connected in common emitter configuration with base current of 30 microamperes. So what he said, what he has given first the transistor was connected in common base configuration, in which the collector current was in common base configuration. Collector is the output terminal, whereas the emitter is the input terminal, right? You have to remember. So the output current is given, which is 2.98 milliamperes, and the input current is also given, which is 3 milliamperes. right? And he has also given IC naught. What is IC naught? IC naught nothing but reverse saturation current. So the current flowing through the collector terminal under reverse bias condition is given here, which is due to the minority charge carriers, that is given by 0.01 milliampere. So this is the reverse saturation current given. Now he asked us to find what is the collector current that flows in the circuit when connected in common emitter configuration. Now, so this is the current given in common base configuration. Now he asked us to find IC in common emitter configuration. First of all, we should know the common collector output current equation in common base configuration. So in common base configuration, we have current amplification factor as alpha. So alpha into IE plus IC naught or else ICB naught. So from this, we need to find out alpha value. So we know this IC value, IE value we know, and IC naught value we know. We have to find out alpha value. So alpha value given by IC minus IC naught divided by IE. Just substitute all these values and find out the alpha value. So now for common emitter configuration, you all know that the current equation that is IC is equals to beta into IB plus IC E naught. Beta into IB plus IC E naught. So first of all, we need to find out beta. How to find out beta? Beta value, if I know alpha value, I can find out beta by using a formula that is alpha by 1 minus alpha. Alpha by 1 minus alpha. From this, we are going to get the alpha value. Just substitute in this. We will be getting this beta value. Right? So if you get the beta value, as it is already given, the IB value is 30 microamperes. Now, not only getting beta value and IB value is enough. We should also calculate IC naught. So we all know that IC naught is a reverse saturation current flowing through the collector terminal under common emitter configuration, which is given by 1 plus beta into ICB naught. This is a formula for this reverse saturation current in common emitter configuration. So you can calculate beta value from this. Substitute. ICB naught is nothing but IC naught, which is already given in the problem. So that is 1 plus beta into IC naught. Substitute these values, then you will be getting the value of IC naught. So you substitute IC naught, beta value and IB value in this, so that you will be able to find out the IC, that is a collector current IC, which is flowing through the circuit when it is connected in common emitter configuration. So this is how you can solve it. So from the given parameters, first find out the alpha value. After finding out alpha, you find out the beta value. After finding out the beta, then you calculate IC naught. Then you calculate IC by using the formula beta into IB plus IC naught. So that so this is the way you can solve the problem here. I'm not going to concentrate about the numericals. I'm just giving you the way to solve this problem. And if you want the answer also, you can just go through my videos, that is problem solving videos on module 2. So that which has been already uploaded in YouTube. So you can just go through them for verifying the answers. Just I'm giving you the idea of solving the problem. Now the next problem is a transistor has IE is equals to 10 milliamperes and alpha is 0.98. Determine the value of IC and IB. So here, what are the values? First, whenever a problem is asked, first you need to note down the values given, the parameters given. So, and alpha value is also given 0.98, and he asked us to find IC and IB. So we all know that. So this is a transistor, alpha value is given. So you know the formula for alpha. What is that? IC by IE. This is a current amplification factor for common base configuration, right? So that is output current in common base configuration is IC and IE is the input current. So from this, you can calculate IC, that is equals to alpha into IE. So alpha value you know, IE value you know, just substitute and find out IC value. So once you know the IC value, you can easily find out IB value. Simply we know that IE is equals to IC plus IB, right? So So as you know this IC value and IE value, just you can calculate IB value as IE minus IC. Okay, so this is one way, or else we can also calculate beta value. So that is alpha by 1 minus alpha, and we know that beta is equals to IC by IB. So as you know IC value, so just you can calculate IB value as beta into IB value as, sorry, IC by beta. Beta value you can calculate it as IC by beta. Either this way you can do or this way you can solve. Both the way you will be getting the same current. Okay, so this is the solution for this. Now let us see. Determine common base configuration collector current for the given parameters alpha 0.98, IE is 3 milliamperes and ICB0 is 10 microamperes. So what is asking? He asked us to find the collector current of common base configuration. Right? What are the parameters given? Alpha given, which is 0.98, and IE value is also given, which is 3 milliamperes. Right? Now he asked us to find IC value. So as it is common base configuration, the value, the equation for IC is alpha into IE plus IC B0. Alpha into IE plus IC B0. So we know that IC value we need to find. And we know this IC B0, and IE value is also known, and then alpha value is also, we just substitute and find it out. So IC we have to calculate, whereas alpha value is 0.98 into 3 into 10 to the power of minus 3, that is IE value is 3 milliamperes, plus IC B0 is 10 into 10 to the power of minus 6. So just simplify and find out the value of IC. This is how we need to remember. So the formula that we have to remember to solve this problem is this one. IC is equals to alpha into IE plus ICB. So next thing, for a common base configuration, RS is 1200 ohms, RL is 11,000 ohms, and H parameters HIB 22 ohms, HRB 3 into 10 to the power of minus 4, HFB minus 0.98, HOB 0.5 microamperes per volt. Find AI, RI, AV, RS, AVS using exact analysis. So we all know that these are the formulas for exact analysis, and these formulas are applicable for all the three configurations of a transistor. So only the thing is, in place of E, we need to substitute HOB, HIB, HRB, so like that. Only the thing is, difference is the subscript will change. So all the exact analysis equations or its parameters are applicable for all the three configurations of transistor. Only the thing is, the H parameters values will be varying. So as we all know these values, just draw the common base configuration circuit diagram. It's H parameter equivalent circuit, and then you just substitute all the values in this equation so that you will be able to find out AI, RI, AV, in AV, AIS, AVS. So only the thing is how to find out AIS, AVS. This is the question. So if you want to find out AIS, AVS, first in order to find AVS, what we should do, we should get the equivalent circuit of the input. So where AV was calculated without considering the source into effect. Now what we need to do, we have to consider the source into effect. Source into effect, if you take the source into effect, then I will have, this is VS and this is RS, and the entire equivalent circuit input can be replaced with RI. So this is RI, RS, and the voltage drop across this one will be VB. Okay, so this one is VS, right? So in order to calculate AVS, so AVS is nothing but V0 divided by VS, where AV is given by V0 by VI. V0 by VI. So what I'm doing, I'm just multiplying and dividing this one by VB here. Okay, so VB. So this is VB, let us consider. So now V0 divided by VB into VB divided by Vs. So where V naught divided by VB is nothing but open loop. That is a gain without considering the source into effect into VB divided by Vs. This is nothing but a potential divider circuit. So from this, how can I calculate VB value? VB is a voltage drop across this resistance Ri. So and hence I can find it out as by using the potential divider principle, that is the input voltage Vs into that resistance, that is Ri, divided by total resistance Ri plus Rs. So that means VB by Vs can be calculated as Ra divided by Ri plus Rs. So that means AVS I can calculate it as AV into Ri divided by Ri plus Rs. So this is as Rs value is known, and you can calculate Ra value by substituting all the H parameters in this. So just substitute, then you can calculate the overall voltage gain, right? Similarly, you can even calculate the current gain. How to calculate the current gain? So the current gain can be calculated, AIS can be calculated as I naught divided by IS. Okay, so where I can write this one as minus IC divided by IS into, I'm just multiplying and dividing this one by IB and IL. I'm just multiplying this one by IB and IL. So here then minus minus IL divided by IB, and then IC divided by IL, okay, into IB by IS, right? So minus IL by IB is nothing but open voltage gain without taking the source into effect, AI. Next up into this one IC by IL. So IC by IL and then IB by IS, right? So for doing this, what I'm doing, I'm taking the output equivalent circuit. So what is the output equivalent circuit we have? We have, this is RL connected. This is RL, whereas this is R0. This is R0, right? So R0 is nothing but total output impedance here. So the current flowing through this is IC and this one is IL, right? So here now I can say that I can calculate IL as according to the these are connected in parallel. So according to the current divider principle, in parallel current will be dividing. So IL is equals to the input current IC into opposite resistance R0 divided by R0 plus RL, right? So this is how you can calculate this IL by IC value, right? And then we can also calculate next IB by IS. For that, just convert this input circuit into current divider. So how can I convert this current into current divider? This is a current source, this is IS, whereas this is RS. So current divider circuit means the current source in parallel with a resistance. So we do have resistance RA. So now the current flowing is IB. So I want to find out IB. So IB is equals to input current IS into opposite resistance. What is the opposite resistance? RS divided by RS plus RS. So from this I can calculate IB by IS and IC by IL, and so that I can substitute all this so that I can calculate AIS. So this is how you can find out AVS and AIS. For any problem you can do the same procedure where he is asked to find AIS and AVS. So determine the common collector current if beta is equals to 200, IB is 100 microamperes, IC naught is 1 microampere. So what he's asked? So he asked us to find collector current IC, that is beta into IB plus IC naught. Some simple substitution. Beta value is given, that is 200, into IB value is given, that is 100 into 10 to the power of minus 6, plus IC naught is given, that is 1 into 10 to the power of minus 6. Just simplify this and here you can find out the collector current value. So this is how you can find out the collector current. For a transistor circuit having alpha is equals to 0.97, find the value of beta. If beta is 200, find the value of alpha. So we all know for solving this problem we should be aware of the relation between alpha, beta and gamma. So that is, first of all, alpha beta is equals to alpha by 1 minus alpha, and similarly alpha can be given by in terms of beta as 1 plus beta. Okay, so first what is given? Alpha is given, that is 0.97. We need to find out beta value. So how to substitute? Use the formula, that is 0.97 divided by 1 minus 0.97. So just you can get the value of beta for the given value of alpha. And similarly, he has given beta value, that is 200, and he asked us to find alpha, which is beta divided by 1 plus beta. So beta value is 200 divided by 1 plus 200, approximately 0.9 something we'll be getting. So like that, we should be aware of this relation between alpha, beta and gamma. Even we can have the gamma in terms of alpha as gamma is equals to 1 by 1 minus alpha. So these are the relations that we have to remember. Now, eighth problem, that is determine common collector configuration emitter current if gamma is equals to 201 and IB is 200 microamperes and ICE naught is 1 microampere. So, what is the formula here? So, in common collector configuration, so that is IE is equals to gamma into IB, because in common collector, base is the input terminal and emitter is the output terminal. So IE is equals to gamma into IB plus gamma into ICE naught. So just substitute these values and find out. IB is given and ICE naught given. Substitute and find out the value of this. So this is the common collector configuration, where we all know that gamma is equals to 1 by 1 minus alpha, right? So next up. So that is about that kind of problems. Still we have, if any problems are there, so the model will be like that. Only the thing is, the numericals will be changing. So for solving the problems in transistors, you have to be aware of, or else you have to remember the formulas related to current components of transistor and also the characteristic parameters of transistor amplifier, like voltage gain, current gain, input impedance, output impedance, using H parameter model. Okay, so that is how you can solve. I hope you can now solve any kind of problems that are given on hybrid parameters, right? Or even alpha, beta, gamma. Now we'll be discussing long answer question. How to answer some of the questions, theoretical questions asked based on the transistors. So determine Q point of voltage divider bias transistor CE configuration, or explain the DC and AC load line analysis of BJT. So for these two questions you can answer in the same fashion. So that is why I have clubbed these two questions and I am discussing the answer or the solution for these two questions here. So determine the Q point. Q point is nothing but operating point. How to fix the operating point? First, what we need to do, we need to draw the common emitter as it is as common emitter configuration. We have to draw the common emitter configuration circuit like this and its characteristics. So we all know that the characteristic curves are drawn between the input voltage, input current, and also the input current and output voltage and output current. So we are taking the output characteristics of transistor. So these are the common. This is a common emitter configuration, a PNP transistor connected in common emitter configuration. So the thing is, first draw the common emitter configuration transistor connected as an transistor, and then its output characteristic curve, which are drawn between the VCE and IC, and then define load line. What is a load line? What are the different types of load lines? That is DC load line and AC load line, which are to be drawn on the output characteristic curve. AC and DC load line, define AC load line, DC load line, and draw the AC load line and DC load line. How to draw the AC load line and DC load line? First, we need to identify a point on x-axis as well as a point on y-axis by taking current as 0 and voltage as 0. So this is the KVL for writing KVL for the output loop. So which is VCE. Okay, this is VCE plus VCE minus IC into VCE is equals to VCC minus IC into RC. That is, this is VCC, let us consider, minus VCC plus VCE plus IC into RC is equals to 0. So if you rearrange the words terms here, VCE is equals to VCC minus IC into RC. From this equation, we are going to find out the 2 points which are intersecting the curve on x-axis and y-axis. Just join them together. Then what you'll get? You will be getting the equations like this. Okay. So, and then AC load line. So, DC load line, you have to explain the DC load line and AC load line. How to draw the DC load line on the characteristic curve, how to draw the AC load line on the characteristic curve. Once the load lines are drawn on the characteristic curve, they will be intersecting at one point, and that point of intersection of both AC and DC load lines on the characteristic curve is said to be operating point. Okay. So, this is the operating point. So, and for a transistor to operate as an amplifier, it should be located in linear region of operation. That means it should be in the middle. Either it should not shift towards the cutoff region or towards the saturation region. Even that point also you should mention. So, this kind of answering will be sufficient for that. Draw the circuit diagram, explain what do you mean by DC load line, AC load line, how to draw the DC load line, AC load line on the characteristic curve, draw the output characteristic curve, and then draw the procedure for drawing the load lines, and the point of intersection of those two will be the operating point. Just mention this way, you will be getting full marks. Now, what are the factors to be considered for selecting the operating point Q for an amplifier? So, as we all know that transistor should be operating in active region, then only it performs the amplification operation. If it is operating either in saturation or cutoff region, it cannot be working as amplifier, right? So, now depending on the location of operating point, we will be finding the various applications for transistor. So, the factors, what are the factors that are affecting the operating point? How the operating point can, based on what factor the operating point is shifting either towards the saturation region or cutoff region. That reasons you have to mention here. So, the major reasons are the temperature and the ICB0. As the temperature increases, ICB0 will be increasing at a rate of, that means for every 10 degrees centigrade rise in temperature, the ICB0 doubles. As ICB0 doubles, IC will be increasing, which will be affecting the VBA. So, these are all the factors which are, as we see IC is varying, operating point obviously shifts. So, these are the various factors which are affecting the location of operating point. Now, demonstrate the working of common emitter transistor in common emitter configuration and draw its output and input characteristics, right? So, first of all, you have to define what do you mean by common emitter configuration. Write down a point. So, that is common emitter configuration, base is the input terminal, collector is the output terminal, and the emitter is a common terminal for both input and output. This point you have to mention. And then draw the circuit diagram. Either you can take an NPN transistor or PNP transistor connected in common emitter configuration. Provide the biasing such that the emitter to base junction is forward biased and collector to base junction is reverse biased. Okay. So, this is a circuit diagram. Draw this one. And the PNP semiconductor bar structure of NPN transistor. This is the NPN transistor. So, draw the circuit diagram and then explain some few points about this operation of this transistor in common emitter configuration. So, what happens? What happens near the junction when the input voltage is applied is increased and when the reverse voltage applied across the output junction is increased? What happens? How the charge carriers are moving from one junction to the other junction. So, just write some few points on the operation of transistor in common emitter configuration, right? And then give this current relations related to the common emitter configurations, right? Just take this derivation part. So, you have to derive these expressions so that you will be getting some 2 marks or something here. And then finally, draw the input characteristics and output characteristic curve. So, whenever you are drawing, you are asked to draw the input and output characteristics. First, you need to mention input, put the heading as input characteristics and write down the procedure for drawing the input characteristics. What is the procedure? Keep the output voltage as constant, increase the input voltage VBE in steps, and note down the current IB, and that is the input current IB. Plot the graph between VBE and IB by taking voltage on x-axis and current on y-axis, and it will be just similar to the PN forward biased PN junction diode characteristics. And if you observe, when VC is 0 and 10, 20, as the VC is increasing, so why the characteristic curves are moving away from the origin? You should mention the reason why the characteristic curves are shifting away from the origin, and you should highlight it so that you will be getting full marks here, right? If you mention that that point by highlighting it, so that you will be getting full marks. And similarly, output characteristics. How to draw the output characteristics? So you should mention the procedure. Keeping the input current as constant, vary the output voltage, that is VCE, increase the VCE, and then note down the collector current, that is output current. Draw the graph between the output voltage and the output current, taking output voltage on x-axis and output current on y-axis. And the characteristic curve will be like this. It is having 3 regions of operation. How the transistor operates in 3 regions of operation? You just mentioned 2 points, few points regarding this. First, take the cutoff region. Why it is said to be in cutoff region? What happens? What is the amount of current flowing through the junction in cutoff region? So what happens in such saturation region? When it is said to be in saturation region? And active region. So just mention few points about cutoff, active and saturation region. And what happens if I increase the current, input current? So how the characteristic curves are shifting. So just mention them by highlighting some of the few important points so that you will get full marks. So these are the characteristic curve. Now let us see the next question. Explain the working of transistor in common base configuration and draw its input and output characteristics. So the same way, first define common base configuration and draw the circuit diagram of transistor in common base configuration. Either you take NPN transistor or PNP transistor, but the biasing should be proper. If you take NPN transistor, the emitter junction should be emitter terminal should be connected to the negative terminal of the battery, and base terminal is connected to the positive terminal. Similarly, the output side, collector terminal, as we need to reverse bias, as a collector is N-type, so the positive terminal of the battery is connected to the collector, and negative terminal of the battery is connected to the base. So like that, you should check the polarity of the potential supplies, DC supplies given, and even the current polarity, in what direction the currents are flowing, that you have to check. So first define the common base configuration, draw the circuit diagram, and then explain some few points related to the operation of a transistor in common base configuration. So what is the junction, what is the depletion layer width at the emitter junction, depletion layer width at the collector base junction. So what happens when transistor is connected in common base configuration, how the currents are flowing, so that you have to mention, and give some current relations. What is the current relation in common base configuration? Common base configuration, IC is equals to alpha into IE plus ICB naught. Just derive this expression and derive the value of alpha and beta. Okay, so from like that, you should mention some mathematical expressions, explain some few points related to the operation of common base configuration transistor, and then draw the input and output characteristics. So here also, first give the procedure, how to draw the input characteristics, and what happens if the collector to base junction, that is the output voltage, is increased further, how the shift is happening in the characteristic curve. So in case of common emitter, the characteristic curves are shifting away from the origin, whereas in this common base configuration, what is happening? What happens if the output voltage is increased? So the curves are shifting towards the origin. So why it is happening? What do you mean by early effect? And due to this early effect, the shifting is happening. Okay, so you just define early effect or else base width modulation while explaining the input and output characteristics. And these are the output characteristics. So the same way, how to draw and what are the regions of operation, just explain. So this is the common base configuration. Similarly, common collector. Explain the working of transistor in common collector configuration and draw its input and output characteristics. So first define common collector configuration, draw the circuit diagram, and then give some mathematical expressions related to the common collector configuration, and even mention some of the points related to the operation of transistor in common collector configuration, and draw the characteristic curve by mentioning the procedure. And why the curves are here, if you observe to the previous one, the characteristic curves are falling down, whereas in the previous case, as the voltage is increasing, the current was increasing. But here, as the input voltage is increasing, the current was decreasing. Why it is happening? You just mention again. So this is also again due to the early effect. So how the early effect is affecting the input characteristic of transistor in common collector configuration. And these are the output characteristics. So again, a procedure to draw and explain the operation and explain the regions of operation, and that is all for this common collector configuration, right? Now, next one, show the H parameters of bipolar junction transistor in a small signal model. So as we all know that transistor can be represented using H parameters. That means the equivalent circuit of transistor can be drawn using H parameter model. So what are H parameters? How to derive the H parameters? Just write down these two equations which are giving the H parameters, and the matrix form of representation of this H parameters here. So this is a two-port network. Transistor can be represented as a two-port network. So just find out the H parameters here and draw the equivalent circuit by considering this two equations. This is the input equation and this is the output equation. As the input equation is in the form of voltage, this is nothing but forming a closed loop at the input side. And this is a parallel connection of resistors at the output side. So this is the equivalent circuit. Just draw the equivalent circuit and define each and every parameters. What is H11, H12, H21, H22. Just define all these parameters, and the other names for these H parameters you just mentioned. So that is how you can answer this question. So next, so that is H parameters, and then how the transistor can be represented as represented using H parameter model. So we are this is done. So once the H parameter model is developed for a two-port network, now I want to apply this for a transistor, where the transistor can also be considered as a two-port network, right? So only the thing is, just replace the transistor by its H parameter equivalent circuit, and the remaining all the elements should be connected as it is. So this is the equivalent circuit of H parameter transistor, to which a voltage source in series with a resistance are connected at the input side, and a load resistor is connected at the output side. So this is finally the H parameter equivalent circuit of a transistor. Now determine H parameters for the common base configuration using NPN transistors. So for answering this, first of all, define H parameters. What are H parameters? Why these are called as H parameters? H parameters are nothing but hybrid parameters. Just mention 2 points why these are called as H parameters, that is hybrid parameters. Draw the circuit diagram for common base configuration of NPN transistor. This is the common base configuration of NPN transistor and its equivalent circuit, H parameter equivalent circuit. So these are the definitions of H parameter equivalent circuit. Explain the common emitter configuration using H parameters, right? So this is common emitter configuration. Again, NPN transistor, its H parameter model. How can we write down the equation? In common emitter, H parameters, that is, first of all, common emitter, base is the input terminal. That means VBE and IB are the input parameters, and collector is the output terminal, that is VCE and IC are the output parameters. So here, what should we do? Input voltage and output current are mentioned as the function. So input voltage, which is VB, is a function of IB and VCE, and similarly IC, that is output current, is a function of again IB and VCE. Right? So I can write down the equations for this one, VBE, or else in short we can write it as VB is equals to HIE. As it is common emitter configuration, HIE, we need to add one more parameter, HIE into IB plus HRE into VC, HRE into VCE or else VC. And similarly, IC can be written as HFB into IB, HFE into IB plus HOE into VC, HOE into VC. So these are the equations, and from these equations I can derive the H parameters like HIE is equals to VBE by IB by keeping the output, by keeping the input circuit as or open circuit. So like that, you just mention how to calculate all these parameters. So this is common emitter. Next up, draw the small signal model of common base BJT amplifier and derive the expression for voltage gain, input resistance, current gain and output resistance. So this is the common base configuration BJT amplifier, and this is the equivalent circuit, H parameter equivalent circuit of common base configuration amplifier. And then we need to apply the KVL and KCL at the input and output nodes, and we have to derive the equations for AV, RI, AI and R0. So just we derive this equation, applying KVL, KCL and all, we can derive all these characteristic parameters. By applying this KVL, KCL and all, voltage divider principle, current divider principle, we can derive the equation. So these are all the equations. So just write down the derivation of all these expressions for this common base configuration. Draw the circuit diagram, equivalent circuit, and then step by step you have to apply the KVL and KCL and derive the equations for all the parameters like AV, RI, AI and R0. So this derivation also we have discussed in some theory lectures. You just go through them for the derivation of this characteristic parameters of amplifier. Okay, so just I am giving you the way how to present here. Right, now determine the H parameters from transistor CE configuration, input and output characteristics. So he asked us to determine the H parameters from the characteristic curves of input and output characteristic curves of common emitter transistor in common emitter configuration. Just draw the circuit diagram of transistor in common emitter configuration and draw it, and you mention some few points regarding the common emitter configuration and draw the input and output characteristics of common emitter configuration. Just mention some few points how the characteristic curves are drawn. The input characteristics and output characteristic curves are drawn. Just mention them and draw them. Once it is drawn, just calculation from the graph. From the input characteristics, we will be measuring the two parameters, that is input impedance and reverse voltage gain. So how to measure this? You just mention few points here. And output, from the output characteristic curve, we will be measuring the output admittance and voltage gain, forward current gain. So which is HFE. So just mention this so that you can be perfectly answering that question asked. Now define the following, that is active region, cutoff region and saturation region. So we all know that we have three regions of operation for transistor. What are the three regions of operation? Active, cutoff and saturation. So when a transistor is said to be operating in cutoff region, active region and saturation region, you just mention few points and you draw the output characteristic curve and you represent which region is said to be active, cutoff and saturation. Like this you mention. Not only drawing this, you should mention some points how to define a saturation region, cutoff region, active region, how to identify them in the characteristic curve, what is happening there. So that you have to mention here. So that is the definition. Now explain base width modulation in common base configuration. Base width modulation, as you all know that the variation of effective width of the base region with respect to the variation in the reverse voltage applied to the collector to base junction of transistor is known as base width modulation or else early effect. So just draw the diagram and show it effectively. So as a collector to base junction is reverse biased, the depletion layer at the collector to base junction is more widened and it will be more penetrated into the base region because the base region is very thin. And hence the effective width of the base will be decreasing, in which the recombination takes place. As a recombination, the rate will be reduced. So due to which the base current is reduced. So this is what's said to be early effect, which in turn increases the collector current and hence at one point of time, this current, more current will be flowing through the transistor. So, and hence the device may get damaged. That effect is called as punch through. So, this is how you can explain the base width modulation with neat circuit diagram and neat points. You can explain base width modulation. Next, list the formula used for conversion of common emitter H parameters into common base and common collector. So, common emitter parameters all you know, HIE, HRE, HFE and HOE. So, from all these, I want to calculate HIB, HRB, HOB and HOB. Right? Similarly, I want to calculate common collector parameters HIC, HOC, HRC, HFC. Right? So for that we need to have some conversion formula. Just list this. Up to this it is enough. This one and this one it is enough. These are the conversion formulas for converting the H parameter, common emitter H parameters into common base and common collector. So these are the various types of questions that may be asked. And one more thing I forgot to tell you. He may be asking you to find the relation between alpha, beta and gamma. So that you have to remember. And so these are some of the kind of questions that may be asked based on module 2. I hope now you will be able to answer any kind of question that can be asked from the bipolar junction transistor. That's all for this lecture. If you have any doubts and all, you can just go through my theory and problem solving lectures for any kind of solutions, so that you will be able to understand how to answer any particular question. So that's all for this lecture. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.